Hello students, good morning to all. So today we'll continue our discussion of lesson 1, networking concepts. So today we'll study about the domain naming system. So first of all, we discuss about the domain name. That what is the domain name? Domain name is a unique name given to the each website or resource which is connected on the internet. Okay, and these domain names are easier to remember, like the facebook.com. Then Facebook is the domain name. So it is very easy to remember that if you want to open the home page of the Facebook, so just you will type on the browser www.facebook.com or only simple for facebook.com you are typing. Okay, now the IP address domain name is given to the certain IP address. Now each domain has a unique IP address, so it is difficult to remember the IP address because IP address is of 32-bit, and to remember the numbers is a difficult task. So that's why this domain name request is given to the DNS server, which is called the domain name server, and the domain name servers contains the IP address of each domain name. Okay, so the request of this domain name facebook.com is sent to the DNS server. Now in the DNS server, the IP address is searched for the domain name Facebook. Now on that place it will place the IP address, which is of 32-bit. Okay, so and after that the request will be sent to that server which has this IP address. Now this domain name is a symbolic string associated with the IP address, means each domain name is associated with an IP address, and there are several domain names available. Some of the generic such as, see, the domain name is given commercial, edu, educational, gov, government, net, network, like this, while some country domain name also says for EU, for Australia, IN for India, ZA, and US for USA. So basically this domain name system comprises of domain name space and name server. This name server is responsible for finding the IP address of the corresponding domain name. Now see here, some domain names are given, like com is used for the commercial business, edu for education, gov for government, int for international entity, mil for US military, net for networking organization, org for non-profit organization, and here some domain name representing the country. So the country top level domain names: AU Australia, India, CL Chile, FR France, US United States, ZA South Africa, UK United Kingdom, JP Japan, ES Spain, DE Germany, CA Canada, EE Estonia, HK Hong Kong. Okay. So and also this domain name system is a system in which the domain names are translated into the internet protocol, which we have discussed that domain names, DNS is the system in which the domain names are translated into the IP address or internet protocol, and the internet works only with IP addresses. Without IP addresses, we cannot fetch any web page. It serves as a this domain name serves as a directory for the web by locating and addressing devices in the worldwide network. So this domain name consists of basically two parts. One is the name of the domain, another is the web extension. The name of the domain comes before the dot. Before the dot symbol is the domain name, and after the dot it is the extension. And the web extension tells the kind of organization, means which kind of organization it is, a commercial, educational, government, military, or non-profit organization, all these things which we have studied. Now you can see here, many domain names are there: ES, com, commercial, commercial also MTG, house, Paulian, UNH, government, educational, ORG. These are the hierarchy of the extension. In the above diagram, each subtree represents a domain. Each subtree is a domain. ES is also a domain, this is also a domain, this is also a domain, this is also a domain. Each domain can be partitioned into subdomains. See here, one main domain is partitioned into the basically 1, 2, 3, 4, 5 domain: ES, com, gov, educational, organizational. And after that, educational is partitioned into subtree Colorado, another one, and the Colorado CS, EE, and the CS is Maria, Roxy, Kim, like this. Okay. So next is the name server. Name server contains the DNS database. This we are talking about the domain name server. This database comprises of various names and their corresponding IP address. What is contains various domain names like facebook.com and others, and their corresponding IP address. Since it is not possible for a single server to maintain the entire DNS database, Therefore, the information is distributed among many DNS servers. And the hierarchy of the server is same as the hierarchy of names. So entire namespace is divided into zone. So this DNS is divided into many zone, and each zone contains the database of the DNS. Here you can see zone is a collection of nodes, that is the subdomains. Here the education zone contains this much. The server maintains a database called zone file for every zone. You can see here edu, emu, Stanford, Berkeley edu zone. This is the csberkeley.edu zone. These all are the domain name server. If the domain is not further divided into the subdomains, then the domain and zone refers to the same thing. This is zone and it is subdivided into this. This is also subdivided. Now next you can see the name servers. So three categories of the name servers are there, which manages the entire domain name system. Three types of the name servers are there: root server, primary server, secondary server. Root server is the top level server which consists of the entire DNS tree. It does not contain the information about the domains but delegates the authority to the other server. It is a root server, top level server which contains the entire DNS tree. You can see hierarchy. Primary server stores the file about its zone. Primary server stores the file about its only zone, particular zone. And root server contains all the zone. It has the authority to create, maintain and update the zone file. Secondary server transfer complete information about a zone from another server. It transfers the complete information about a zone from another server, which may be primary or secondary. That is the secondary server. The secondary server does not have the authority to create or update zone file. So you can see how the DNS works. So DNS translates the domain name in IP address automatically. So we follow the steps. Will take you through these steps included in the domain process. Suppose here written www.tutorialspoint.com in the browser, and it asks the local DNS server for its IP address. What is the IP address of this tutorialspoint.com? So here the local DNS is at ISP send. So when the local DNS is the ISP send. So internet service provider will send this request to the local DNS. So when the local DNS does not find the IP address of the requested domain name, then it forwards the request to the root server, DNS server, and again inquires about the IP address of it. The root DNS server replies with the delegation that I do not know the IP address of this, but know the IP address of DNS server. So again, the local DNS server then asks the commercial DNS server the same question. The commercial DNS server replies the same, that it does not know the IP address of this URL, but knows the address of the tutorialspoint.com. Then the local DNS asks the tutorialspoint.com DNS server the same question, and this URL or DNS server replies with the IP address of www.tutorialspoint.com, and now the local DNS sends the IP address of www this to the computer and sends the request. Like this it happens. Okay, now we move to some protocols. We'll study about the protocols one by one. So basically, what is the protocols? So protocols are the certain rules which determine that how the data should be transferred over the networks, and how it is compressed, how it is presented on the screen, and so on. So, protocols are the rules, certain rules which determine how the data will be transferred, how the data will be exchanged over the network from one computer to the other computer, and how the data is compressed and presented on the screen, and so on. Okay, so there are many protocols, and each governing a certain technology on which we work. As the basic needs of protocols is to standardize the process, and the ways of communicating over a computer network. So over a computer network, we should use a standard protocol, a standard process which every client, which every device technology should follow. Okay, so first protocol we will study, that is the TCP, transmission control protocol, or the internet protocol, IP. TCP protocol, see the transmission control protocol. So this TCP is a connection oriented protocol and offers end-to-end packet delivery. It acts as a backbone for connection, and it exhibits the following key features. So this TCP is a connection oriented, means first of all it is help us to establish the connection between the two computers, or more than two computers over the network. So this is a protocol to connect the various computers on the internet. It provides end-to-end data communication, specifying how the data should be broken into pieces, that is called the packets. So it also divides uh, the data into number of packets, and the data is transmitted over the network in the form of packets, transmitted and how they routed from one network to the other until they reach their destination. Means they divide the information data into the packets and transmit them and route it from one network to the other network until they do not reach their destination. So what we can say, TCP is a combination of two separate protocols, TCP protocol or IP protocol. And this TCP, transmission control protocol, or also we can say transfer control protocol, is used for the reliable and foolproof data transmission. It is used for reliable and foolproof data transmission over the network. Responsible for also dividing. TCP protocol is responsible for dividing the data into packets. So which protocol divides the data into packets? TCP protocol, and at the center sites, and also assemble these packets in the correct order at the destination side. So some sequence number is also given to the each packets, that is the numbering 1 2 3 4 like this. Packet number 1, packet number 2, suppose 1 GB data is divided into 100 packets. So packet 1, packet 2, packet 3, like it will send in the same sequence. First packet 1 will be transmitted, after that packet number 2, then after packet number 3. So this transmission control protocol corresponds to the transport layer of the OSI model, that is the open system interconnection. This is the network model. So this TCP is used at the transport layers, and TCP is reliable and connection oriented protocol. TCP offers stream data transfer, reliable, efficient flow control, full duplex operation, and multiplexing. Okay, so some other we will see here. TCP services. TCP offers services to process the application layer. At application layer, this offers the following services: stream delivery service, sending and receiving buffers, bytes and segments, full duplex services. Okay, so leave it, this is not the part of your syllabus, so no need to go through that. Now, full duplex service means transmit the data in the duplex mode. That is the flow of the data in both the direction at the same time. Like you are talking on the telephone, mobile, that is the duplex channel. Means at one time, simultaneously both can speak. TCP offers connection oriented service in the following manner. Next is the internet protocol C, which is also a part of the TCP. So this internet protocol is a connectionless and unreliable protocol. So here the connection is not established. It ensures no guarantee of successful transmission of data. So IP is, in order to make it reliable, it must be paired with a reliable protocol such as TCP at the transport layer. Now this internet protocol provides a sequence number. So this each packet, TCP divides the data into packets, and on each packet sequence number is assigned by the IP protocol. So this internet protocol provides a sequence number to each of these packets so that they might reach their destination in the correct order, so that the packets reach in the destination in the correct orders, and also it handles the addressing of each packet so that it is delivered to the correct destination. Now see what does this IP contains. So internet protocol transmits data in the form of datagram. You can see this 32 bits, IPs of 32 bits which you have studied. First 4 bit is used for the version, which type of packet it is, which type of the information it is, version, header length, what is the size of the header, means where the information, DS type of service. So 8 bit of, it is used 4 bit for the header length and 8 bit, see here 8 to 16 bit is used for the DS type of service, and 16 bit is used for the total length of 16 bits here. Now after that another identification of 16 bits. This 16 bits is identified. This out of 16 bits of total length, first 3 bits is for the flag and 13 bit is called the fragmentation. This is also not a part of the syllabus, but I am showing you what does this IP contains. As you can see here, time to leave, for what time the packet should be available on the network. If suppose in that time it will not reach the correct destination, so the packet will be lost, packet will be destroyed. Next is the protocol. What type of packet it is? HTTP packet or FTP packet, means file transfer protocol or HTTP protocol. This information is here. Header checks of bits, 16 bits, to check the information that it is the correct data or not which is sent. Okay, for checking it is the. Now here source IP address. So this IP contains the, for who is sending the packet and destination to whom the packet is to be delivered. So both address, source IP address and destination IP address, contains the IP protocol. This is called this is the packet, and here option plus padding. Okay. So the length of the datagram is variable. Datagram is divided in two parts, header and data, and the length of the header is 20 to 60 bytes. Header contains information for routing and delivery of the packets. Okay, so this is all for the today, students. In the next class we'll continue our discussion, and we will study about the HTTP protocol, SMTP protocol, and POP protocol. So this is all for today. Thank you for your kind attention.